everyone. Today we are doing our solving a quadratic equation by graphing. So in our previous unit, we solved by solving the equation, which we involved factoring. Now we're going to learn how to find these roots or solutions by graphing. So the solutions of a quadratic equation are called the roots. They're also sometimes called the zeros, and they are the x-intercepts. So to find the x-intercepts by graphing, what we do is we start out by graphing the quadratic. So remember, the best way to graph a quadratic is to start by finding the axis of symmetry. So our axis of symmetry is x equals negative b over 2a. In our first example here, a equals 1 and b equals 4. So that means x equals negative 4 over 2 times 1. So our axis of symmetry is x equals negative 2. So when we use our calculator to look at our table, we want negative 2 to be our middle value for x. So we use our graphing calculator. So we go to y equals and we enter that equation. And then I'm going to take a look at my table. So I want to definitely see negative 2. So negative 2 is negative 1. That is my vertex. And I know that this parabola opens upward because a is positive, so it has a minimum. And then I look at points below. So negative 3 is 0, and negative 4 is 3. Negative 1 is 0, and 0 is also 3. That is my y-intercept. So I plot this. So negative 4 is 3. Negative 3 is 0. Negative 2 is negative 1. Negative 1 is 0, and 0 is 3. Oops. Not the best at drawing the lines here sometimes. There, that's better. So the solution is where f of x equals 0. So our solution to this parabola is x equals negative 3 and x equals negative 1, because that's where it crosses the x-axis. In our table, it's where y equals 0. Now I should always label my parabola with the function f of x equals x squared plus 4x plus 3. So now I'm going to graph the next one. So again, I'm going to start by finding my axis of symmetry. X equals negative b over 2a. A, here's 1. B is negative 6. So x equals negative 6 over 2 times 1. Negative 6 is positive 6 divided by 2 is x equals 3. So that is my axis of symmetry. So when I make my table, I need to make sure that 3 is included in my x values, because I always need to see the vertex. So again, I go to y equals, and I'm going to enter that equation. And then I look at my table. You can see in my table that 3 is 0. 4 is 1, 5 is 4, 2 is 1, and 1 is 4. So I plot my points. And this time, my parabola only touches the x-axis. Just touches. So this is when we did it factoring, that our two solutions equaled the same. So in this case, my solution is x is 3, which is my x-intercept, which in my table is where it equals 0. So I want you to pause the video, and I want you to graph the next 3 and find their solutions. So number 1, notice that it equaled 0. So in order to solve it, I actually made it y equals x squared plus 7x plus 12 so I could graph it. I then found my axis of symmetry by doing x equals negative b over 2a. B in this case is 7. So my axis of symmetry is x equals negative 3.5. So it's important that I include that in my table. And again, I made it in my table by once I was in my table, I did the plus sign to change my table to make it go by 0.5s. You can also do that by doing second window, and there you can change what your table goes by as well. So in my table, I only graphed negative 3.5. I didn't care about the other halves. I just needed that axis of symmetry, that vertex. This is my minimum. So I plotted my other points. So I did negative 5, 2, negative 4, 0, negative 3.5, negative 0.25, negative 3, 0, and negative 2, 2. My solutions are where x is 0, or where y is 0, sorry. So it's x equals negative 4 and x equals negative 3. So again, pause and do number 2 and 3. So on number 2, again, it was really important that I found that axis of symmetry by saying that a equals 1, b equals negative 1. So my axis of symmetry is x equals 1/2. It's important that I include that point in my table because I need to know where it turns. Then you'll notice in my table, I didn't do all my numbers. I made sure that I extended my table though to see where x is or where y is 0, because those are my solutions. I graphed it. It's really skinny down there by my turning point, but the solutions are x equals negative 3 and x equals 4. Number 3 again, I found my turning point. These turning points or these axis of symmetries tell me where to center my table. So when x equals 2, y equals 0. So not only is x equals 2 my axis of symmetry for this one, but it also happens to be my solution. If you have any questions on those, please let me know in class. Now, the other thing is sometimes our solutions aren't whole numbers. They're not pretty like those ones. So when we're estimating the solution, the roots of a quadratic may not be integers. The exact roots cannot be found graphically. They can be found estimated by finding the consecutive integers between which the roots lie. So for example, when we want to solve x squared plus 6x plus 6 by graphing, the integral roots cannot be found. So what we do is we graph f of x equals x squared plus 6x plus 6. We made our table. We made sure we had our turning point. But notice nowhere in my table is it exactly 0. My roots are these 2 points right here. So notice that the value of the function changes from positive and negative between negative 5 and negative 4, and then again between negative 3 and negative 2. The x-intercepts of the graph are between x equals negative 5 and x equals negative 4, and they are also between x equals negative 3 and x equals negative 2. So the one root is between, this one sentence is missing something. So let's forget about this sentence. So one root is between negative 3 and negative 2, and the other root is between negative 5 and negative 4. And I wrote it wrong up there. Sorry about that. It's negative 5 and negative 4. They're between negative 5 and negative 4 and negative 2, or I'm sorry, negative 1 and negative 2. I totally messed this up. I apologize. So let's make sure we get that. Our solutions are between negative 1 and negative 2, negative 5 and negative 4. Negative 1 and negative 2, negative 5 and negative 4. So let's do another, that extra line being in there that was wrong kind of threw me. So let's do example 1 together, or number 4 together. So again, What I want to do is I want to graph this function. So to graph this function, I replace 0 with f of x. I need to find my axis of symmetry. So a equals 1, b equals 7. So my axis of symmetry is negative b over 2a. So in this case, it's negative 7 over 2, which is negative 3.5. So I make my table, and I make sure negative 3.5 is in my table. Use my calculator, so I go to y equals, I'm going to graph x squared plus 7x plus 9. Look at my table. I want to see what's happening at negative 3.5, so I hit the plus sign, change it to go by 0.5. Okay, so negative 3.5 is negative 3.25. So then below that, I'm going to do negative 4, which is negative 3. I need to switch from positive to negative. So I need to keep going. So negative 5 is negative 1. And negative 6 is 3. I then look, see what happens down at the other end. So negative 3 is negative 1. Or negative 3. Negative 2 is negative 1. Negative 1 is 3. So I plot those. So negative 6 is 3. Negative 5 is negative 1. Negative 4 is negative 3. Negative 3.5 is negative 3.25. Negative 3 is negative 3. Negative 2 is negative 1. And negative 1 is 3. So here's my parabola. And my roots, or my solutions, are here and here, which are not integral values. So my roots are between so the first one is between negative 6 and negative 5. So x is in between negative 6 and negative 5. My second one is in between negative 2 and negative 1. So I want you to pause, and I want you to try 5 and 6, and then come back and check. Okay, so number 5, again, I found my axis of symmetry by doing x equals negative b over 2a. My axis of symmetry is therefore 1/2. So I made sure I included 1/2 in my table, and I saw that 1/2 is at negative 4.25. I did values until it went from negative to positive. So I graphed that. And then you can see that my two roots are in between negative 2 and negative 1, and positive 2 and 3. Number 6, again, I found my axis of symmetry by doing x equals negative b over 2a. Found my axis of symmetry is x equals 2. I made a table and I plotted points, and my range goes from 2 up, so it never crosses the x-axis. Therefore, that is a situation where I have no solution. So this is the end of our video for today. If you have any questions, please ask me in class.